Okay, Fibonacci sequence. So, this is first explained by an Indian mathematics Virahanka between 600 AD to 800 AD. So, Fibonacci sequence has the numbers 1, 1, 2, 3, 5, 8, 13, and so on. So, this sequence which can be found in some plant parts such as leaves and petals. So, later, didiscuss ko sa inyo kung paano nakuha yung mga numbers sa Fibonacci sequence. So, it is named after Leonardo Bonacci, 1170 to 1250, and also known as Leonardo of Pisa or Leonardo Fibonacci. He is known as the most talented mathematician of the Middle Age. So, eto siya, si Leonardo Bonacci. Ito yung picture niya. So, in 1202, Fibonacci wrote a very famous book, Liber Abaci, described mathematics he had learned. So, these are studied as part of number theory and applications in the counting of mathematical objects such as sets, permutations, and sequences, and to computer sciences. So, Fibonacci numbers can be seen in our four fingers. Tingnan nyo, kuhanin nyo muna yung inyong, tingnan nyo yung kamay nyo. So, bawat tao, merong dalawang kamay. So, sa dalawang kamay, lahat tayo ay may 5 fingers. So, ang isang finger, meron siyang 3 part. Kung mapapansin natin, tingnan nyo, yung knuckles natin, yung pinagkikiluan ng ating daliri. So, we have 3. So, all this fit into the sequence. So, this is an example of Fibonacci numbers. Again, ang tao may 2 kamay. Ang 2 kamay ay may 5 fingers. Ang bawat isang finger ay merong 3 parts na hinahati ng 2 knuckles. So, lahat yan ay part ng sequence. Sabi niya, dun sa kanyang book, if 2 new rabbits are put in a pen, how many rabbits will be in the pen after 1 year? So he need to assume that rabbits always produce 1 male and 1 female offspring and can reproduce once every month, can reproduce when they are 1 month old and never die. So, kailan lang sila pwedeng manganak? Pwedeng manganak lang sila kapag katapos ng 1 buwan. Okay. So, this is the example or the figure of the Fibonacci sequence o yung kanyang tanong, yung kanyang experiment. So, isang pares muna, 2 lang, newborn. After 1 month, nanganak. So, hindi na mamatay yung magulang, tapos nagkaroon another offspring, and so on and so forth. So, dire-diretso siya. Mapapansin natin 1, 1, yung pares ang ating binibilang. Nung first, we have 1, and then lumaki, nag-mature yung newborn rabbits, naging, hindi naman sila nadagdagan, kasi sabi dun sa rule, pwede lang silang manganak after ng 1 month. So, newborn rabbits, after ng 1 month, nag-mature na sila. Then, nanganak na. Kasi pwede na daw silang manganak. So, meron pa rin isa, nandun pa din dun si rabbit, yung unang rabbit, and then, nagkaroon sila ng anak. Again, so, meron tayong 2 pares ng rabbits. Next, for the 4th month, eto na tayo. So, 3 rabbit na. Bakit? Kasi, isa yung unang rabbit, then yung kanilang anak, and then yung anak nila na naging mature na. So, kung matitingnan ninyo dyan sa pattern, padami siya ng padami, hindi siya nababawasan kasi sabi sa rule, and they can never die. Okay. So, the Fibonacci sequence is a series of numbers where a number is found by adding up the 2 numbers before it. So, starting with 0 and 1, the sequence goes as 0, 1, then 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13, and so on. So, para siya ay makuha natin yung numbers, i-add natin yung unang dalawang number bago yung sagot. So, lagi tayo nag-start sa 0, 1. So, dito, so we have 0 plus 1 is 1. 1 plus 1 is 2, and so on. The succeeding numbers in the sequence is determined by adding the two previous numbers. So, the Fibonacci sequence are nature's numbering system. So, ito daw yung ginagamit or makikita natin sa nature. They appear everywhere in nature, from the leaf arrangement in plants to the pattern of the florets of a flower, pine cone, or the scales of a pineapple. So, siguro, hindi natin napapansin na, okay, may sequence pala yung mga yon. Kasi, hindi naman tayo aware na meron silang sequence. Ngayon lang natin nalaman na ang nature pala is full of patterns. So, the Fibonacci numbers are therefore applicable to the growth of every living thing, including a single grain, a grain of wheat, and a hive of bees. So, dito, makikita natin paano ba lumalaki yung mga bubuyog. So, a non-recursive formula was discovered by Jacques Binet in 1843. When the values in the sequence is analyzed, the proportion of adjacent terms begin to approach a fixed limiting value of 1.618034, and so on pa yun. So, merong formula na imbento para malaman kung ano ba yung nth number ng isang Fibonacci. So, ano ba yung formula na iyon? So, this proportion is commonly known as the golden ratio, but originally known as the golden mean of Euclid and Aristotle, and the divine proportion of Leonardo da Vinci. So, the formula for solving the nth term of a Fibonacci sequence is f of n is equal to 1 over square root of 5 times 1 plus square root of 5 over 2 quantity raised to n. So, ang papalitan mo lang diyan kapag kukuha ka ng value or kukuhanin mo yung nth term ng Fibonacci sequence ay yung letter n. Yun lang ang papalitan. So, for example, find the 10th number of the Fibonacci sequence using the formula. So, solution, meron tayong dalawang solution using the formula, and the other one is using the table. So, using the formula, so we have f of n is equal to 1 over square root of 5 times 1 plus square root of 5 over 2 raised to n. Papalitan lang natin yung value ng n kasi ang hinahanap natin is 10. We are looking for the 10th number of the Fibonacci sequence, so pwede ito ang gamitin. Palitan lang yung value ng 10. And pwede mo siyang idiretso sa calculator. Kapag napindot mo siya sa calculator, ang lalabas sa kanya is 55. So, ganito yung pwede nyong i-type sa calculator. Kasi kailangan doon madaming parenthesis. Kung hindi nyo makukuha yung sagot. Again, papalitan lang yung value ng n, kung ano yung hinahanap na number. And that is one solution. Another solution is using the table manually. So, ito yung table natin. So, sa taas, we have the nth term, kung ano yung hinahanap. Dito tayo hanggang 10. And then sa baba, yung x sub n. Ayun yung kailangan nating isolve. So, n stands for the number of Fibonacci sequence we are looking for. Since the problem is looking for the 10th number, we number the table from 1 to 10. So, ito depende sa kung ilan number ang hinahanap nyo. Pero, mostly, kapag medyo malaking number na hinahanap, for example, 100 number of the Fibonacci sequence, so, syempre, hindi natin gagamitin yung table. Medyo mahirap. Pero, kung konti lang, siguro hanggang 20, kaya pa siyang isolve using the table. So x sub n stands for the value of Fibonacci sequence we are solving. We will start with 1 and 1 for the first two numbers, then add them to get the third number. So, umpisahan natin ang kanina sabi ko 0. Huwag na natin isama yung 0. So, dahil counting numbers tayo, we started at 1 and end at 10. Kasi, sabi ko nga, 10th number of the Fibonacci sequence using the formula. And, start tayo. Ito 1. So, 1, 1. Ito yung dito tayo start. Add natin 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. And 21 plus 34 is equal to 55. So, parehas lang ang makukuha mong number kahit pa yung gamitin mo is the formula and also the table.